So in this video, I want to revert to some basic terminology that you should know before entering 7th grade that will help you deal with the types of math that we try to do. So the first, I want to get through some definitions. Odd numbers, remember, are numbers that you cannot divide by 2 to make whole numbers. So those will all be things like 3 and 1 and 5 and so forth. Versus the even numbers, which are numbers which you can divide by 2 to make integers, or whole numbers. That's what an integer is. That's another definition. An integer is a whole number, positive, negative, or zero, right? No fractions, no decimals. It's just a whole number, right? So if you do 2, 4, 6, 8, all of those can be divided by 2 and still give you another number that can be divided by 2. And so that is an even number. Now, natural numbers are just the integers that do not include negatives. And before 7th grade, that's mostly what you worked with. You worked with rational numbers, and you did some rational numbers too. You did some fractions, you maybe did some decimals, but they were always positive, right? So now you're going to actually work with rational numbers of all kinds. These are all numbers that can be written as fractions. Negative numbers, positive numbers, decimal numbers, numbers that can be written as fractions. There's also irrational numbers, which are numbers that go on that cannot be written as fractions, like pi. And we're going to have one example of that later in the year. But for now, we don't have to worry about that. So those are basic definitions of things you should know by now. There's also this concept of prime numbers. So prime numbers are numbers that can only be divisible by themselves or 1, not including 1, right? So you have 2. There's nothing you can divide 2 except for 2 and 1. And the same thing for 3 and 5 and 7 and 11 and 13, 17, 19, 23, and it keeps going forever. There's an infinite number of prime numbers, but they're the ones that cannot be divided by anything other than themselves and 1. They don't have any factors. Like, for example, if you look at 12, 12 can be divided by 3, it can be divided by 2, 15 can be divided by 5, 27 can be divided by 9. So those aren't primes because they have factors, all right? So the next thing I'm going to talk about is your friend, the number line. Remember, the number line is just when you make a graph of the numbers. And they don't have to be the whole numbers. They can be fractions. They can be whatever you want. 0 is that middle of the number line. It's neither positive or negative. Numbers to the right of that are considered positive integers or your positive whole numbers. And in between those integers, you have the fractions, the other rational numbers. So remember when I said natural numbers, what I meant were all the numbers starting from 0 all the way to the right. That will be the natural numbers. Now, negative numbers will be the ones to the left of 0 on the number line. They are numbers which are smaller than 0. And they make sense when you think about a depth that is below the sea level, or if you think of losing money like a debt, right? Or if you think of negative temperatures because it dropped below 0. So that's how I think of it when I think about that. Or a position to the left of the origin if you're thinking about in terms of physics. Now, opposite numbers are numbers which are an opposite sides of the number line, but equally distant from 0. So for example, 4 is 4 digits to the right of 0. So negative 4 would be its opposite because it's 4 digits to the left of 0. So that's pretty straightforward. An opposite number is the same number, but with an opposite side. They're also called additive inverses because you can put them together and actually make 0. So if you put 4 plus negative 4 will give you 0. Right? They're the same distance from 0. That's why that happens. Now, absolute value just means looking at that distance, how far you are from 0. So negative 4 and 4 are just as far from 0 as the other. They are 4 units away from 0. So the absolute value is the distance from 0 that the number is on the number line. So all you have to do is take away any negative that you see in a number, and that will be its absolute value. Okay? Positive numbers, the number is already its absolute value, but in a negative number, you have to take away that negative sign. The next thing I'm going to talk about is the difference between the words difference and distance. So if you hear the word difference, that means subtract. That means finding the difference between the two numbers by doing one minus the other. So for example, the difference between A and B is A minus B. But that's different from saying the distance between A and B. So let's look at an example. Let's look at 3 and 2, or 1, sorry. Okay, but I want the difference between 1 and 3 in that order. 1 and 3. So the difference between 1 and 3 would be 1 minus 3, which, following the rules we learned earlier, you have to slash and then slash, and therefore 1 plus minus 3 is negative 2. So the difference between those numbers is negative 2, but the distance between them is clearly just 2. So in other words, the distance, it's kind of like the absolute value of that difference. So the distance is the absolute value of the difference. There can be no such thing as a negative distance because it's just the space between two numbers. Right, let's do another one as an example. If you look at negative 4 and negative 2. So remember, always in the order they give you, the difference between those numbers, between negative 4 and negative 2. So there you do negative 4 minus 2. So the difference between those numbers, as bizarre as it sounds, you have to slash here and then change the sign of the next number. That becomes negative 4 plus 2, which is negative 2. So the difference between them is negative 2. But the distance between them is the absolute value of that, which is just 2 units. Okay, so that's the difference between difference and distance. So hopefully that's clear. The last key term that I want to talk about is this idea of reciprocal numbers. Reciprocal numbers are numbers which are kind of inverse of each other. So like here you see 6 over 1 is the inverse of 1 over 6. Another example of that is, let's see, 6 over 3 would be the inverse of 3 over 6. And another word for that is reciprocals. Now, the cool thing about reciprocals is that they're also called multiplicative inverses because when you multiply them by each other, your answer is 1. So let's do that as an example, right? So 6 over 3 times 3 over 6. You get 6 times 3 equals 18. And then 3 times 6 is also equal to 18. And 18 over 18 is just going to be 1. And so that is a property that is always true of numbers which are reciprocals. When you multiply them, the result is 1. Like 6 times 1 is 6. 1 times 6 is 6. 6 over 6 is 1. That is going to be true of all reciprocals. So that's it. On the next video, I'm going to talk about some basic properties of adding, addition, and multiplication, which help you solve a lot of arithmetic problems. And I'll see you guys then.